Yeah, so if you check our data sets, we have different categories of data. We have categorical data. We have, for example, the gender data. The column is a categorical data type. We have known amounts to be number, so we have it in diversity like that. But to work with scikit-learn or in order to train your machine learning models, we have to convert those columns into numbers. So that's the part we are going to do now. Or let me put it this way: we have to encode our all our categorical variables. And when I mean encode, it means you are going to take it from the concept of encoding in statistics or computer is like we have in gender, we have male and female. That thing that Ayobami was trying to do is encoding. So wherever it is that there is one, it replaces it with wherever there is male, it replaces with one, and wherever there is female, it replaces it with maybe 0. So that's the concept of encoding. So the value still remains, but then it has changed it into another format that is useful for us. So let's see. Let me bring in a code that does that. Now there is a module, label encoder, that we can see in our scikit-learn library or package. So I gathered all the, what's it called, categorical tables, data type rather. And I think when we inspected the data set yesterday, we saw those ones that were categorical. Almost all of those that are in object data type, almost all of them are categorical variables. So you will notice that they are the ones I returned there. You can't see loan amounts or applicants' low income. You are not seeing those ones because those ones are already in numbers. So we are not dealing with those ones. So what I'm trying to do here is to encode the categorical variables. So what we do the work for us is this our encoder. You understand? We call this label encoder, which is in this module, and this module is in this particular library. So we call this model, we create an instance of it, you create an object of it, and we call it LE. Are we following? So we use our loop to say for high in var mode, like all these variables that I've stored here, from gender, marriage, dependent, education, all of that. So for each of these, it's going to take this instance of label encoder, and then it's going to fit transform. Now this fit transform is one that will do the work, and then change whatever it is that is here and start encoding. So it's one that actually does the work of encoding. So let's see how this works. So if there is no error, it's working. But then let me view our data set again so that we can see if that is affected. So let's see. Let's just check some few, the first 20 things in our data set. So let's see how that is. So can we notice any change?
Yes.
So it has encoded these guys for gender. It's added 1 for male, and then let me see the value, and 0 for female. You understand? For
Yes.
for married, 0 and 1 for the two values. You know, I think what was there was yes or no, I think. So it's encoded that too. For dependent, I think we have about 3 values there. So it's added 0, 1, 2, representing each of the values. So wherever's independent or not independent was before, it's just going to replace the value. That's what this is doing. For education, what was there before was undergraduates and it was graduate and not graduate, right? So it's replaced it with 0 and 1, 2. The same thing with self-employed. So we can move on now. So this is the concept of encoding. That's the concept of encoding. Now, after encoding, the next thing we are going to do is to go ahead and start our training. You understand? Now, I don't know if I've introduced us to the concept of machine learning, but machine learning is I think someone gave us a brief explanation yesterday. So all the techniques we are going to use today, they are defined in machine learning. They are machine learning techniques. Now, machine learning is used for mostly all the data science algorithm that you are seeing. They are also machine learning. Like your linear regression, your random forest. Those are actually machine learning methods or techniques. So it's just generally machine learning is just a study of computer algorithms. You understand that we actually automatically improve, or that automatically improve through experience. So it's a process of allowing your machine to learn. That's just the concept. So when you give a machine a data this time, and then it's able to improve in its performance by training on the data you have given to it. That's the process of making a machine to learn. So when you train algorithm for the purpose of improving performance over time or improving experience automatically over time, that's just the general concept of machine learning. So it gives your machine the ability to learn. That's just the general concept. So we'll move on. So there are different there are broadly two categories of machine learning algorithms or techniques. We have supervised and unsupervised, although there are other ones, and that was why I specified broadly. You will hear supervised and unsupervised. There are also reinforcement learning and all. So that is these classification are based on the kind of data that they take. If it's supervised learning, that means it's going to take a data that has label already. If it's unsupervised, it will take data that does not have label. In the case of these data sets, it has label. And what do you think I mean by label? And then
Okay. Okay, like they have names for each value set.
Okay, not really. Not really.
Okay.
So when I say labels, I'm talking about that our target. You know, in this data set, the data set was supposed to be for loan allocation, right? To predict whether
Yes.
this user will get loan or not. So there's already an output. That's what I mean by label. So there's already an output that says whether each candidate here or each observation in our data set was given the loan or not. You understand? Which is this column that has loan status. That's our label in this case. You understand?
Okay.
In some
Yes.
instance, you might call it a class label, or you call it a target. So it's the variable we are trying to target itself. So when you have a data set of this nature, the machine learning tasks that you are performing is going to be a supervised learning. You understand? But when we have a data set, there are some data set that they don't have output. There's nothing known about the kind of prediction they have made before. So those ones, they are called unsupervised, and that's where you have clustering. If you have heard of clustering. But for supervised learning, is either you are doing a regression task or you are doing a classification task. If it's regression, you are either predicting numbers and all, but if it's classification, you are predicting in form of maybe categories and all of that. So that's just by the way. So that's just so the task we are going to be performing this evening is basically I'm going to be introducing us to to supervised learning. We are going to be using all these algorithms that we have here. There are examples under supervised learning: decision tree, your random forest, your logistic regression, all of those. Now we have to import those libraries or those modules before we can access them, and they are made available inside scikit-learn. Are we following? So they are made available
Yes.
inside scikit-learn. So we have to access them. So this is the code to actually bring them on board. So from scikit-learn, I imported the logistic regression. From the same scikit-learn, I imported random forest classifier. From same scikit-learn, or specifically from trees, I imported decision tree classifier. This one, it's now you should read about each of these classifiers or algorithm. They train data in different way and in different format, but then you are expected to be getting close to the same output. Now, based on the data set that you feed into in any machine learning task, what is most important is not your algorithm you are using, but the data set. You understand? So the data set you are using to train is what is most important because it influences, and that's why the first part of our work was important. You cleaning your data, making sure there is no any form of dirtiness in your data. So that's it's very important because you can't just feed anyhow data. If you feed anyhow data, there can be either overfitting, underfitting, or even the data is just predicting something that is not in line with what it's supposed to predict, like that. So I imported metrics, I imported train test splits. When we start using each of these, I will show you the application of them. Now, there's no error, this has imported. So let's take this. Now we are going to use our logistic regression. The way logistic regression works then, it takes two variables, you understand? Two independent variable and dependent variable. What I mean by independent variable are those ones that are determinants of the output. You understand? The dependent variable is the output, the one that is depending on others to be able to tell us what happened. So the output here, the dependent variable here is what? Is our credit status. Is that credit status or loan status, right? Then independent variables are all of those ones. So they are the ones that in one way or the other were joined together to be able to know if this person gets the loan or not. So they are called independent. They're not depending on anything, but the output is depending on them. So that's just the concept. So now we are going to do that. We are going to get the independent and dependent variable to train. And like I said, logistic regression takes two variables. You understand? So come in. Come in, I'm setting something. Yeah, so I've not, I don't, okay, I've not run this. So what I'm doing here is just basically telling, I'm saying go and get the columns. What iLock is used for is to retrieve columns. You understand? There is also lock. If I'm using lock, what I'm going to be passing in is just going to be the name of the specific column we are trying to access. Are you following? But for lock, for iLock will take index. You understand? That's just like saying index location. You understand? So it's going to take the location, sorry, the index of that particular column you are trying to access. So in this case, what I want us to first predict with, or to predict with the 8th column and the 10th column, and that's our, I think that's our loan amount and credit history. So we want to use loan amounts and the credit history to determine if to determine the loan status, if this person will be given the loan or not, and then we assign that to X. You understand? As our independent variable, we are taking two out of the other ones. Then we assigned for Y, we picked the last, the 12th column, which is our result column, which is loan status, and we store that in Y. So let me run this code. Yeah, good. One thing about this notebook is if it runs, you won't really see any output. So far, you're not printing anything anyway. So unlike our which one were we using before? Spider. Yeah, where you see are supposed to be seeing this X and Y somewhere around there, but I don't think it's okay. Wait, let me check data. Okay, it's actually not showing.
I'm seeing it actually.
You're seeing it. Which side are you seeing it?
But I'm seeing, I can confirm. I'm using Spider. I'm still using Spider.
Okay. You are seeing it in Spider, right?
Yes.
Yeah. So you get what I'm trying to say. But then it's
Yes.
all good. So far it's not showing error. That means the code ran or it runs. Whatever the correct English is. Now, when you're training a model in machine learning, you have to divide your data sets. Broadly, or most time you divide into two, which is your training set and the test set. What do I mean by training set? The training set is the part of the data set you want to use to train the model. Are we getting it? Is the one you want
Yes.
to use to gather pattern. I think we're talking about pattern the other day. Like you are trying to learn a pattern in the old data set and stuff. So it's the one you are trying to use to learn. You understand? Is your training set. Then the test set is after it has learned and gotten a pattern. After it has learned and the model has been trained, then we want to test with something that was not part of the training process. Do we understand? Which is our test set. So your test set is one that tests the predictive power or performance of your model. So let's go on. So now we have to split the data set. That's what I want to do now. So that's what this line of code is doing. I think you can see that I'm doing a lot of copy and paste. I have my code in Notepad already today. I think I said that yesterday. That instead of me typing each
Yes.
line by line, I'll just be pasting it and then be explaining it. Now for this, what it does is this, it uses this train test split, which we imported somewhere here. Yeah, here. Do we get it? We imported it from this scikit-learn model selection. Now what that method will do for us, or function will do for us, is to help us to split our data sets that we're passing into it. Now you see that we pass X. What is in X? The two columns that we are taking as our independence variables. What is in Y? Our columns that we are using as our dependent variable. Now I said the test size is 0.25. What's the implication of that? Now this is more or less like specifying the percentage of the data set you want to use as a test set. Now the general thing that is advised, or that is even supposed to be normal, is your training sets must be much more than your test sets. You understand? Because you need more data to train. If you train, so I said we are using logistic regression. Now this is the code to do that. I created a variable called classifier. So I called this logistic regression function, which we have imported here from scikit-learn model rather. Then I pass my random wherever inside that. So if I run this, okay, I think there is a message in the chat. You can hear.
Responding to Alima, to Mustafa, I will do for you.
Okay, thank you. I think his network has been somehow since day one.
Yes.
Yeah. Sorry, I would do. Sorry, oh. So please let me. I think maybe a she or he. I don't know. But then, so I've addressed this. I've run this rather. So after creating a classifier, what you're going to do is to fit the model. You understand? With the data set. I think he's logging in back. Yeah. So now fitting the. How do you fit? There is a function called fit. Sorry. Can you hear me now? Okay. So we are going to fit the model to the data now. So the two things we've done up here, we're bringing it as one. So these are model, which is our classifier that we have created here, our logistic regression model. So now we want to fit our data, which is this X train and Y train. Now, can someone tell me the stage where we are in this our training? From what I explained the right time, what stage are we now? What are we doing? While I'm waiting, I'm going to run this.
We are learning the model.
We are doing what?
We are learning the model.
Yeah, I don't know if the word learn. Yeah, we are making the model learn.
Training.
We are training. Yeah, training.
Yes, you're
Training is
training.
what I expect though. So after you have trained the model, how do you know if the model? How do you then test? So the part of testing is you now using your data set that was not part of this training process, and then use it to predict, to make prediction. Elbami, please be running this code on your laptop because you helped me share so that I want to show something to them on the Explorer plane.
Okay.
I really wish I'm able to use
Okay.
the spider. And I use it on my system, but if I should connect this Zoom on the system, what happened the other time will happen again.
Okay.
Unless I use another account to log in. So now, to be able to test the model, what you're going to do is to your Y, I created a variable called ypred, and then I used this same classifier, which is my logistic regression, and then I did dot predict. When you are training, you do dot fit. You understand? You are fitting the. Okay, this will still go off in the next 10 minutes. So let's confuse. I think I'll be still complaining. Can't hear a thing even after logging in and out. Is his system or let me tell him that I should check what ask him what device he's using to log in. Maybe phone. And ask him if he didn't. You should just check his audio. That's what I think. Just check his audio. Because for everybody. So as I was saying, so you predict when you want to do your test, what you are doing is you predict. So I do classifier dot predict. Predict what? Predict our test sets. You understand? So I'm saying there is a model that have been created, that have been fit or that have been fitted or that have been trained. Then now I want to test it. So to test it, I want to tell it to help me predict. It's like you have trained a medical doctor and then you're not telling the doctor now take this person that is sick and heal the person. So you are now going to compare what the person has learned to what the person is being able to do in the practical space. Yeah, so let me run this. I don't think I'll run this. Okay, so this is the prediction it makes. Again, the way this one is printing it, I don't like it. But then I think I will use my Obama's laptop to show us the difference between these and then the other one. Now, how do we know if this prediction, how do we know if the prediction is actually correct or right? How do we test the performance of the model? Because behind every, maybe should I say most of the software that I see, okay, let's cite example now, Netflix. From what I read or heard, for Netflix, they use, of course, they use machine learning or should I say data science now. They trained their data, I think, over the years to then, so that's what confusion metrics will help you to generate. So it's able to help you get the accuracy or performance, because if it's predicting wrong, if it's, let's just assume this COVID-19 test, let's say they bring out an online platform for us to be doing the test, and then 80% of people that log in, they are having COVID-19. You understand? You will know there is error in the data that they use to train or in the training process entirely. So there have to be a stage where you test the performance of that model before you can bring it out to the market and come and sell it. So you check some online platform, we have maybe online doctors, expert system and all of that. where you can just go and give your symptoms, and they're able to predict if there is, if you have cancer or not. So those things, they are based on machine learning. So the decision being made is as a result of training on data that exists before for that particular disease. So that said, can we see the confusion matrix?
Yes.
So from what I explained, which one, okay, maybe I didn't actually show us. Let me see if I'm able to get a picture. Are you seeing the other side of my screen? Can you see the new page?
Turn it up. Yes.
Okay, so I'm trying to see if I can see a picture of confusion matrix. Confusion. So that I'll use it to explain something to us. Which one should I click? Which one should I click? Okay, let me use this slicer. Yeah, you see the way it is, like a matrix. That's what it is. If you see this one that has colored, you see it, true positive, false positive. So I want us to note what is in each of those boxes that it's printed out for us now. So this first one is the one representing the true positive. The second one is the false positive. So all the positive values. Yeah, the second row is one representing the negative value. So it starts with the first negative and then the true negative. And then the true negative or something like that. Now let's go on. Sorry. I hope that showed the right thing. So here is the real negative thing. You understand? That's the true negative.
Yes.
And then this is the true positive. You understand? So these were predicted as positive, and then in our data, they are actually positive. You understand? These were predicted as negative, but then in our data, they are not negative. These were predicted as positive, but then in our data, they are not supposed to be positive. So this, just draw a kind of diagonal line from here to here. I mean, slants between 19 and 109. Those are your important values. Those are the right predictions. If you cross to the other side towards the left, 24 and 2, those are your false predictions. You understand? So this is telling us that out of, if you sum this together, you must have the total of rows that we have in our test sets, our Y. You understand? I really wish I'm explaining this using spider. Okay, so good. Do we understand what I'm trying to say? So let's
Yes.
if we log out now. Sorry, less than 1 minute, but then I'll still run this. So another way to actually check the accuracies or to check the performance is to calculate the accuracy score. How accurate is the model? Because you can't write a model for a medical line and then it's not accurate. It's just making wrong predictions every day. It's telling people they have malaria when they don't have malaria, telling them they don't have when they have. So I hope we are getting the concept of the prediction and then the confusion matrix, positive, false positive, and all of that now. Okay, so this is the output of our confusion matrix, and I've explained it earlier and how. So let's go on and get the accuracy, which we have gotten on that. I will just, so that we can also have it in this. I'll just copy that, then paste it here. Okay, so the same result. So I said we should change the algorithm that we use, right? So let's use decision tree. I think we imported 3 algorithms there. random forest,
Yes.
decision tree,
Decision tree,
and down. So let's,
logistic regression,
yeah.
and
So
linear regression.
we've used logistic regression. Let's use random forest. Sorry, let's use decision tree. Now, all I have to do is just run this part again. So that means my classifier now is going to be decision tree. So you can read more about each of these algorithms, these techniques. They have different way of operation. Classifier to decision tree classifier, but I didn't change it on your laptop.
Yeah, I didn't see it, but I've changed it to. I've added it to the list.
Okay.
Yes, thank you.
So now I think I've not run this part. So this is the, please note the difference between the confusion metrics of the first one and this one. So we'll be able to judge which algorithm actually is predicting better. Can we see it?
Yes.
So by mere seeing the confusion metrics, which algorithm will you choose out of the two?
I think the logistic regression.
Logistic regression proceeds more.
Yeah. So that's because, of course, that one predicted correctly more than this and all. So this, let's check the accuracy of this one. Obviously, see the accuracy of this one, 0.72 something. Yeah. Right. So let's also try random forest, which is the last thing we try this night. This laptop will actually go up in 10 minutes. I just want that to be the end of the class. And then okay, can we check this one? Does it outperform any of the two?
I think it's
I think
close
it's
to
almost the same with
the logistic